Welcome back. In this video, I will explain you how to write code in C for preorder traversal in a binary tree. A recap to how to create a binary tree. You have this structure for each node, and these are the three members, CAD data for this A, B, and C, all this stuff. And you have this left and right pointers for pointing to left child and right child from each node. You have insertion function which receives a CAD type data to insert that data into a newly created node. You have also a root pointer which is pointing to null initially, and both of these are of struct node star type. Here is the insertion function which receives data as a parameter, and it creates a node using the malloc function pointed by this mnew pointer, and with the help of mnew the data will be stored inside the new node and left and right will be set to null, and after completion of this job this mnew will return the new node to the calling statement. Now let us look in the main. This is the insertion call with the argument A. So this will be called over here and A will be stored inside this data variable. Now this mnew will create a new node and store the data inside the mnew's data variable, and mnew's left and right pointers will be set to null and mnew will be returned to root. So this new node has been created with A inside and A is pointed by root. Similarly, in the second statement you see that root's left will be pointing to the new node created by the function insertion B like this. And here is your new node with the data B inside, which is pointed by the left pointer of root. So in this way, we can create a binary tree like this. During coding for preorder traversal, we will use this tree as a sample. Here is our tree, and here we have a stack. This stack will be utilized for storing the addresses of the right children of the nodes. These are the assumed addresses of the nodes. Here, the addresses have been given in integer form. Actually, in computer, it will be in binary form, rather hexa form. This is your structure, and this is your insertion function. Now we have our main here. We declare an array of struct node star type with the size 20 and a pointer root set to null. Now in the figure we have 7 cells because to handle this small tree 7 cells are enough. Now there is a choice variable for these choices, and we have a top set to 0 here, and we set stack top to null. Now we go for the while loop. First you have the choice from the user. Of course, during the first run of this program, you must ask the user to press 1 to create the binary tree first. And whenever the binary tree will be there, your root will be pointing to the node at 781, because this node at 781 is the root of the whole tree. Now the code will be here in this ... area. The code I have explained in my previous video. So in this video, we will go for explaining the choice 2. Now we declare a popped item pointer of struct node type and another pointer ptr. Now we set the ptr and the popped item to root. The duty of the ptr is to handle the current node in the tree, and the duty of the popped item is to hold the address of the popped item from the stack. Now this popped item has been set to root for one reason. The popped item can take two values, one null and another is not null. Not null means there may be root, there may be left child, there may be right child. Out of these three, the not null will be only meant for the right child, because only the right children will be there inside the stack, rather the addresses of the right children. So it has nothing to do with the root's address or the left children's addresses. So it is safe to initialize this popped item to root. Now we run a do while loop here within this while loop, and first we should check whether there is a right child there or not according to your algorithm. PTR is standing on the root at 781. Before moving towards a leftmost path according to our algorithm, we must check whether there is a right child or not. If there is a right child, that means PTR right not equal to null, you increment top by 1 and then you store the PTR's write address inside the stack top. So PTR is at 781, PTR's write address will be 291. So 291 will be stored here. You may print PTR's data and write child's data in this way for keeping track of the progress. Now this do while loop will run until it gets a null value. So popped item is not null means the do while loop will be running. Whenever the popped item will be null, that means this null here will come out of the stack, then you will declare that your traversal is over. Now this is the second block and this is an if-else pair. The if block says if PTR left is null, that means no left child, then you run this block. Else, that means PTR's left child is not null, that means there is left child, then you run these two statements, right? Now for your convenience, I have copied the previous if block over here for checking the right child. Now let us get back to this figure. PTR is standing at 781 with 291 as a right child that has been stored inside this stack. Now we want to move towards the leftmost part. But before moving, we have to check whether there is a left child or not. You can see that the left child is there. So we run this else part. The else part talks about the presence of left child. So set PTR to PTR left. That means PTR will come down from here to here. Now you have gone to the new node and you process the data first. So our processing will be a printing job only. So we print the data where the PTR is standing. So B will be printed now. And then this do while loop will run because popped item is still set to root, that is not null. So you check PTR right not equal to null. Yes, it's true because PTR's left is having a right child at 716. So you increment top by 1 and store 716. There's a right child of PTR over here. Next you check the left child. Yes, there is left child. So you come over here to the else part and you set PTR to PTR left. So PTR comes down from 513 to 233. You print the data and you check by this if block whether right child is there or not. Yes, there is right child. So increment top by 1. So top now goes to 3 and stack top equal to PTR right. So PTR right is 449. So 449 will be stored over here. Now we check whether PTR is having a left child or not. You can see that the PTR left is null. So this if block will fire now. In this if block, the first statement says that popped item equal to stack top. That means 449, this is a stack top. This will be popped out and stored inside this popped item variable, right? And then top will be decremented by 1. That is, top will be decremented to 2. And after that, there is another if-else block inside. That means after popping the item, we have to check in the popped item variable whether the item that has been popped out is null or not. If it is null, then you declare that your traversal is over and you write this break statement to stop the loop. And if not, that means some non-null value has come out, then you set PTR to popped item. So here we go, PTR left is null. So we get inside, popped item equal to stack top. So 49 comes over here, top goes to 2 and we check whether popped item is null or not. We see that popped item is not null. So this else block will be executed. We set PTR to popped item. That means PTR is standing at 233 now. It will be pointing to 449 like this. Then you run the loop. You check whether there is a right child or not. No, there is no right child. So there is no stack operation. You check left child or not. No, there is no left child. So you get inside this if block and pop item from the stack. So 716 will come out from the stack. Top goes down to 1 and set this PTR to popped item, right? So PTR will be standing at 716 now. Again, you run the loop because popped item is not null. So you check PTR's right is null or not. See that PTR's right is null. So there is no push operation here. You check PTR's left and you see that PTR left is null. So you get inside this if block and you pop item from stack top and store it inside the popped item variable. So 291 will come out of the stack and it will be stored inside this variable. Now you check whether the popped item is null or not. No, it is not null. So this else part will be executed. Set PTR to popped item So PTR is standing at 716. It will be now pointing to 291. Then you run the loop again, and this PTR write not null will be executed, because you see that there is a write child 116. So 116 will be stored here, and PTR will come down to this place at 397. So after going to 397, it will check the right child. Yes, there is a right child. So 965 will be stored here. It will check for the left child. There is no left child. So it will pop item from this stack. So 965 will be here. This will come out and this will not be there. So chop will be here, and then PTR will be set to 965. So PTR will move from here to here, right? You print the data age, and then you check the right child. There is no right child. You check the left child. There is no left child. And you move over this if block and you pop item from stack. So now 116 will come out, and PTR will be set to 116. So PTR will leave this place and it will move over here. You print the data I, and after that you check the right child, no right child. You check the left child, there is no left child. So get inside this if block and pop the item from stack top. Now you see that this 116 is not there. So null is there actually. So the null will come out now, and it will get stored inside this popped item. Now it is checked that if popped item is null, then you declare that the traversal is over and you execute this break statement to stop the loop. So this is the code for pre-order traversal in a binary tree. In the next video, we will discuss the algorithm of in-order traversal in binary tree. Thanks for watching and take care.